So welcome back to my YouTube channel. We are in the series we are going to learn embedded system for 30 days. We are in day 3 and we are going to learn the core topics which are required for embedded systems. Without any further delay, let's get started with it. So we are in day 3 and these are the topics we are going to cover for today. What happens inside microcontrollers, memory architecture of microcontroller, register concepts, GPIO internal working, clock system basics, and how Arduino uses Atmega internally. How does it works? As you know, every embedded system is incomplete without microcontrollers and microprocessors. Let us get through microcontrollers and microprocessors. Let's have a brief explanation about microprocessors here. Let us assume example of a computer which has monitor, keyboard, and CPU and many other components. But let's take the CPU, the main thing of a computer. It has CPU in it, which is basically built from microprocessors, and the block diagram which it possesses would be like this. It will be possessing input and output peripherals, memory, system bus, and the key microprocessors. Microprocessors have divided into 3 blocks: registers, arithmetic and logical unit, timing and control unit, and interface, which helps the input and output peripherals to communicate with these block for better system analysis. For this instance, let us consider system bus as motherboard. Every other component in CPU is connected to motherboard. Likewise, these blocks will be connected to the system bus using this interface and the memory. So let us get a brief explanation on every block. Registers generally stores the data and instructions temporarily. During the coding of an system, ALU, arithmetic logic unit, it analyzes the data which we get from registers and send for the output under the time circumstances and control unit. Determine the sequence for completing a particular task. That's about microprocessors. So here comes the most interesting topic: Atmega and Arduino internal hardware. Atmega is considered as the brain of Arduino Uno or any other Arduino system. Generally here we use Arduino 328P in Arduino Uno. Atmega consists at basic level CPU, flash memory, SRAM, EPROM, timers, ADC, GPIO ports, and clock circuit. These are the memory devices which are assigned with Atmega microcontroller. The procedure of understanding Atmega goes into 5 blocks. Atmega, that's the brain of the Arduino. Processor, memory, RAM, and timers. These are divided under heavy R. It consists of 8-bit memory and a clock signals of 16 megahertz and memory of 32 KB and a RAM of 2 KB. Generally, an Arduino operates at 5 volts and 3.3 volts. Generally, people assume that Arduino is an microcontroller, but that's wrong. Arduino is an development board which has multiple pins, mainly digital and analog pins, Analog and digital pins. Analog pins are around 5 and digital pins are 16 pins. These are further divided as PWM and input pins and output pins. There is a symbol beside the number which indicates PWM. PWM is a continuous wave signal which we can observe it during LED blinking experiment. Arduino possesses 3 modes: high mode, low mode and read mode. Read mode depends on the input. There are some functional buttons. TX, which indicates when the Arduino transmits the data, there is an indication of an LED which blinks that tells the data is been transmitting, and when the LED is on at RX, it indicates it is receiving the data, and a reset button so that we can overcome any error during the implementation of Arduino. We would have ground pins that are 2 ground pins, so it also have an V input voltage input button which would give 7 to 12 volts of voltage for the Arduino board. These analog pins are denoted as A0, A1, A2, A3 and A4, A5, which helps convert analog to digital. These are about 10 bits, so that would become 1023 bytes of memory. Digital pins are assigned between 0 to 13. Here the brain model of Arduino would be 8 mega 328P. 32 indicates the memory of the microcontroller and 8 bits of CPU, and P indicates the power optimization for the chip. So let's get more deep into the structure of 8 mega internal architecture. So CPU executes instructions, control all the operations. Arithmetic logic which are used for arithmetic logic units, registers and control unit perform the task to execute instructions. Memory of 8 mega. There are 3 types of memories: flash memory, SRAM and EPRAM. Flash memory, which stores the program code. You might notice that .hex files during the execution of Arduino codes in Arduino IDE. These are non-volatile and 32 KB in size. Non-volatile indicates that when the system restarts, the code which we have written would not be erased. It stays and be stored in this 32 KB of size. Here comes the second type of memory, SRAM, which is used during the execution to store variables, tags and function calls. During the code, we might adjust the variable value which we need as a temporary. It only has 2 KB of memory for storing it, and it's gonna be very fast as we need to change the values successively. And EPROM, this is the permanent data storage model which stores values and data. It's gonna be non-volatile and small in size. It's independent of the system restart. The data is gonna store when the data is entered into the EPROM. Combination of these 3 types of memory build an efficient storage type in 8 mega. When the value of DDR register is 0, it indicates its input, and when the value of DDR is 1, it indicates output. This port is the output register, which indicates about the voltage level given to the atmega. When it's 0, it indicates that the value of the voltage is low, and 1 indicates high. And the pin register read the input of the register given. Let's understand with an example. When an LED is on, it indicates DDR is high. It means the value is 1, and port, so there would be voltage flowing through the LED, which indicates the value is 1 as the voltage is being flown. Timers, these play a very major role in transferring the data, which are responsible for delay generation, PWMs, signal creation, time measurement, interrupt triggering, and communication model. So atmega is the brain, so it need to communicate with other devices which will be connected through the ports that might be digital or analog pins. Here we are explaining about UART, I2C and SPI, which are communication models. In UART, it's gonna be serial monitor and PC communication. I2C, inter-integrated circuits, have serial communication model and EPROM communication model. SPI, it's gonna be fast and display memory chips. Clock, which controls the speed of transfer. Reset button, it generally resets the data which have been given to the Arduino, or in case of any functional delay, this button helps us to restore and efficiently use the Arduino. Atmega consumes around 5 volts of input or operating voltage. So, how Arduino uses Atmega 328P. Atmega helps Arduino to use power supply, USB interfaces, voltage regulation, clock and reset. The internal procedure and data flow which Atmega helps Arduino to go through is when a button is pressed, it will be going through general purpose input and output. It triggers the register. Later the data is given to CPU for logical performance, and the output is obtained and can be seen through LED blink. Registers and bit level thinking, these are the key components for functioning any type of register. You might be aware of the logic gates and or not, and left shift and right shift and XOR. These are the logic tables for the logic gates. Registers play a very important role. Registers play a very major role in between GPIO and CPU. These are the primary compilers. These store temporary data and quick access on requirement. There are two types of registers: general purpose register and special function registers. General purpose registers are used for arithmetic operations, temporary data storage and calculations. Special function registers are used for GPIO control, timer configuration and interrupt control, along with serial communication and ADC. These are the registers which have been already discussed: DDR, port and pin. The type of syntax which would be written for explaining registers in Arduino is this. Let's get more knowledge about GPIO internal working. General purpose input and output terminals. The internal concept goes like it has input buffer, output driver, direction control logic, pull up and pull down resistors, pin register connection. Pull up and pull down resistors have been covered in D1. So input buffer. When a voltage is given to the Arduino board, it's generally in voltages. Input buffer has the ability to convert it from voltage to digital format for understanding. Output driver allows us to send voltage to external components when the function like microcontroller sends 5 volts of output to an external device. In this case, let's take an LED. When microcontroller completes a task and the output which need to indicate an LED glow would be taken by the output driver. And direction control logic, it controls the direction of DDR register. When the DDR register value is 0, it is taken as the input, and 1 indicates the output. Pull up and pull down resistors, these are used to avoid floating values. When the input is given for the input terminals, the Arduino board works fine, but when the switch is off due to some electromagnetic waves on the circuit, the board might function differently or it might affect the output. To avoid this, we will be using pull up and pull down resistors. The pull up resistor is mainly chosen as default in the industrial purpose. Pull up resistor default value is high and pull down resistor value is default as low. So the clock system of an Arduino, which is also known as heartbeat of microcontroller unit, it provides timing signal that synchronize all the operations inside microcontroller unit. Microcontroller works in step-by-step process. It fetches the program, decodes and then executes. At Mega, the 328P has a clock of 16 megahertz. One cycle could take around 1 by 16 into 10 power 6 nanoseconds. For the calculation of at Mega 328P, it would be 62.5 nanoseconds. Clock control exhibit the properties of CPU, execution speed, timer operation, communication speed, ADC sampling, interrupt timing, and peripheral operations. These are the types of clock sources. Internal clock source, where the clock is being generated inside the circuit. External source, where the clock will be generated outside the source. And external crystal oscillator, where the oscillations are generated using a crystal which is outside the circuit, and clock signal flow inside microcontroller would be clock source which generates clock and which then send it to CPU. CPU performs all the logical operations and the output would be seen at the peripherals. The new type of technology which is being implemented recently is clock prescaler. It divides clock frequency so that it does not waste the excess power to perform a task which can be done at lower frequencies. Assume a clock which works at 16 megahertz. It would be prescaled to 8 megahertz, and now the timer clock can perform the same task at 2 megahertz. Unless the clock would not be synchronized, it always raises an error about data corruption. So that's it for the video.